sorry, I try not to start a problem and then have to finish it later. But anyway, taking the derivative, I'm going to set it equal to 0. The derivative of the bottom here is just 1, so that you leave that top alone. All over the denominator squared. This is kind of ugly to solve even by itself, but if you were to distribute that negative 10,000 in, you would actually be able to cancel out the 10,000x. So you'd have 30,000 over that, and it might actually be to your benefit just to use the graphing calculator, which I can show you how to type that in. Since we had it saved in there already, what you can actually do is just hide that and hit alpha, hit math, not alpha, do the derivative, dx of alpha trace, that's what I was starting to do earlier, y1, when x equals x. Now remember, we only care for your window for x values between 3 and 6. So as I hit zoom 0 to fit in the screen, you'll see that we have the derivative equals 0 at this point. And then we can hit second trace to find 0. Just move your cursor to the left, enter, to the right, enter. I'm pretty close in there. You get 4.098 X or C if you follow or R, I guess, in this problem. So by the Rolle's theorem or by the mean value theorem, that answer is yes, R exists, and that R value is about, I already forgot what it was, 4.098. There you go. And we can do the same thing then, except as I'm reading letter C, change colors for you, the biggest thing that's shouting out at me is greatest. And when I see the word greatest, I'm thinking of extreme, absolute extrema. So that's the extreme value theorem. And again, it just needs to be continuous. Continuous on 3 to 9. And what you need to do then is check what's C of 3, which we found out earlier, C of when the derivative equals 0, but then also C of 9. So we actually found that 4.098 earlier, so that's an extreme. The only thing is I would also double check, if I go back to my calculator, I would want to double check that it doesn't cross the x-axis again from 3 to 9. So if I double check that again, it doesn't look like it crosses the x-axis again, and I would only have to zoom out a little bit to see that. So I think I'm good to go, and I'm going to quit out of this, hit alpha trace y1 parentheses. What's actually nice with if I hit x, it actually puts in that x value that we just found. Your calculator automatically saves that value for x when you found that 0 before. And if you don't believe me by that, we could put in that 4.098, which is roughly 77500 divided by 9. Oh, I guess it's not about the same. What is x then? Oh, I guess it didn't save it. Well, don't believe me then. I guess your calculator doesn't automatically save it. Or maybe what it did is because I went to the window and changed my x value, that's probably what happened, is it saved that 9. Okay, so you got to be careful if you're going to use y of x. So the correct answer should have been that 8213.672. We figured out earlier, where's my calculator? I'll just go ahead and do this again. alpha trace y1 of 3. I guess in that instance, we already figured out the y of 9. And let's change that to a decimal, just so it's easier to compare. 8333. 0.3 repeating. And this one we found earlier was at 8611. 1 repeating. Okay, so which one's the greatest cost? I would commit to this one by the extreme value theorem. So you have to check where the derivative equals 0 as well as the endpoints. Let's see what the answer key says about that. There we go. The greatest cost was that 86.11 and 11 cents. I would still round to 3 decimal places because of calculus. That's what they do. But I can see why somebody would change it to nearest penny based off of the context of the question. All right. And just one more problem. A car company introduced a new car for which the number of cars sold is modeled by that equation. And maybe the first thing you do is identify that t cannot equal -2. So as we start with the first one, find the value of s prime of 2. Just go to your calculator. You probably have to do it anyway for a decimal. I doubt anybody would expect you to know that off the top of your head. And I'm just going to unhighlight that equation because I don't think I need that yet. 300 parentheses 5 minus 9 over x plus 2. There we go. So if I quit out of that, I can just hit alpha trace y1 of 2.5. Oh wait, find the value of s prime. Okay, so that would have been a mistake because we want the derivative. So I wanted the second equation. As we had it saved in here, we wanted the second equation, the derivative of that. Hit enter, and I get 133.333. So S is representing the number of cars. And because we did the derivative, it should be cars per month. So find the average rate of change of cars sold over the first 12 months. That would be doing S. So average is my clue that we're going to do the slope. So S of 12 minus S of 0 over 12 minus 0. So now we're back to y1. Whoops. So I can insert. There we go. And you can change that to a decimal if you want. 1157.143. But I think if you just hit divide by 12, you could leave it like that, or you could go back to your fraction. It wouldn't be that bad. I'm going to leave it as my decimal, 96.429. Cars per month still. So up here, this was an instantaneous, and down here is the average. And I'm going to go to the answer key again just to kind of get those words out. So part A was an instantaneous at 2.5 months, whereas over the course of 12 months, this is your average rate of change. So as you look at part C and start to answer this, is thinking about S prime, that's your slope. Think about the mean value theorem there. So the average rate of change. Well, if you look back at your equation and how I mentioned that the only thing that t cannot equal is -2, so does it satisfy being continuous, being differentiable, being able to do the mean value theorem? And as I scroll down, the mean value theorem applies. We can do this. And I think for the sake of ease, for my ease, I'm just going to show you what's happening is you would want to, so we already found the average rate of change at 96.429. And what he's doing is finding the derivative, and the instantaneous rate of change needs to equal the average rate of change at some point on that interval. So he found the derivative and set it equal to that 96.429. And then, well, he changes the variable from t to c. You don't have to do that. Some people make their students do it. I don't. But that's what he did. Find the derivative and set it equal to the average rate of change, and then solve for c or solve for t, whatever variable you want. And you can figure out that the instantaneous rate of change is equal to the average rate of change would be this decimal, this 3.292. Now I'm going to trust that he used this calculator perfectly. I've learned that that's not always the case. So double check this work and get back to me. And I believe we should be ready. If you pause and get all your notes down, you should be ready for the homework.